Okay, guys, happy Friday. Okay, we're moving on to a different topic. It's a similar sort of topic. It's looking at graphs, but rather than gradients, we're looking at the area under a curve today. But before we start that, there's some useful things we need to know. Okay, before we start. So, put a title area under curve, and this is what you need to. Okay, so if we had a speed or velocity time graph, that might look something like this. Okay, the distance will equal the area under the graph. Okay, we're going to use that. So the distance under a speed or velocity time graph, it's the distance is the same as the area under the graph. Okay, and there's going to be some useful shapes that we use to work out the area or estimate the area. So recap. So I might want to find the area of this sort of shape, and this is a trapezium. So if I was to work out the area of that, okay, the area is half a plus b times h. A plus b are the parallel sides. So in this case, it would be half 5 plus 10 times the distance between them. H is the distance between them, which is 2. And if you work that out, it's going to be 2 times a half is 1. You should get 15 there. So the area of units squared. Okay, so the area of a trapezium is the two parallel sides added up times part times the distance between them divided by 2. Okay, so we're going to use both of those bits of knowledge to work out an estimate for under the graph. Okay, here we go. So EG1. So it says, it will say estimate the area of this graph between these two lines, that line and that line, using 5 equal strips. Okay, so I need to split the area up into equal strips here, and I'm going to do that by splitting up. So 5 equal strips like that. Okay, so we've got 1, 2, 3, 4, and 5. Okay, and I need to work out the area of each of those strips if I estimate it to be a trapezium. Now, lots of these, it will basically be a trapezium, but you can see it's not quite. I get a very good estimate if I make them all trapeziums. Okay, right, let's look at trapezium 1. Now the width, it goes from -10 to 20, so it's definitely 10 across. And the height is going to be an estimate here, but that height's going to be about 240. And the height there, about 160. Okay. I'm going to label them all first. I'm going to draw them all first, and then work them all out. A minute. Shape number 2. They're all going to be of width 10. 2 is going to have a height of 160 on that side, and then on this side, about 100. Okay. Shape number 3. Okay, shape number 3 is 100. It's a bit laborious this, but you've got to just work through it slowly, and it's about 60 there. Okay, shape 4. They're getting smaller now. Still 10. That's going to be about 60. And that's going to be about 40 on that side. And then shape number 5, more of a rectangle. I'm going to just say that's a rectangle this time. 10. And that's about 40 high. Okay, then I need to work through now, and I just need to work out the area of each of these. So the first one is half 240 plus 160 times 10. You've got 2000 there. And if you do this on all of them, just work through these. That's going to be 1300. That one will turn out to be 800. This one is 500, and this is 400. And then if we add all of them together, we'll get a pretty good estimate for the area. Of about 5,000, okay? So the area under that graph, 5,000 units squared. Now, it might ask you if this is an over or an underestimate. So is my estimate bigger than it should be or smaller? Well, it's actually going to be an overestimate because all of my trapeziums there were just above the line. Okay, so it is an overestimate because my trapeziums were above the line. Trapeziums above the line, above curve. Sorry. Okay, so it's an overestimate because they're above the curve, and you might end up with a situation where it's an underestimate. You just need to be careful how you've drawn your trapeziums. Is it above or below the line, and use that accordingly. Okay. Right. Let's look at another example. Okay. This graph shows the journey of a car. Work out the total distance travelled in the first 40 seconds. So it starts at 0, ends at 40 seconds. It's a velocity time graph, so all I need now is the area under the curve, or the graph really, area under the graph. And this is a trapezium in itself, isn't it? The trapezium is exactly, if I look up how wide it is, it goes from 10 to 25, it's 15 across there, 40 there, and it's 20 high. So I can just say that, so don't split it into a triangle rectangle, just use a whole trapezium, so much easier. So the distance is going to equal half 15 plus 40 times the distance between it, which is 20. So if I work that out, I get 550, and this is in meters per second, so it's 550 meters. So that car has travelled 550 meters there. Okay. Right, let's look at a third example, and then you're going to do some questions on this. So it says the velocity of a rocket is shown on the graph below. So this is curved this time. Using 4 strips of equal width, estimate the distance travelled between 1 second and 5 seconds. Okay, first thing you need to do is you need to go to 1 second, which is there. So it's going to be between 1 and 5, which is about there. Okay, and I need to split it up into 4 equal strips. So I'm going to split it up into 1, 2, 3, 4 there. 1. I'm going to, as I do that, I'm just going to make them trapeziums. Okay, that's a long slither. And then all I need to do now is to work out the area of all 4 of those trapeziums and add them together. Okay, so this one here, there's a lot of leeway on what oh, hang on, I need to make sure, yeah, that is 1. Across, there is a lot of leeway here because how you draw the trapeziums could differ. So that's about 1, I reckon that's about 4 for trapezium 1, trapezium 2. And if you set it out like I've done, you're less likely to make a mistake. 9 there. Trapezium 3. And trapezium 4. Yeah. The long slither. That goes down 19, and that's going to go up to pretty much 50 actually there. Okay, and I work out the area for each of these. So the first one is half 4 plus 1. 1 is going to be a half 4 plus 9, 1 half 9 plus 19. 1. This is going to be a half 19. 1. Okay, let's add all those up. So the first one is going to be 2.5. The second one is going to be 13. 6.5. This one's going to be 1909, 14, and this one's going to be 34.5, and then if I add all of those together, I get an answer of 7.57 meters. Okay, so that's how far the rocket will have traveled in the first, between 1 and 5 seconds, which is obviously really useful, practical tool here. Again, you could be asked, is this an over or an underestimate? Again, this is overestimate because your trapeziums, it isn't an overestimate. Because your trapeziums go above the curve, as trapeziums above curve. Okay. And then you also might, how could you make this more accurate? Well, you could make more accurate by increasing the number of strips. Okay, so if you went up to double the number of strips, then the accuracy would get more and more and more. And those doing Maths A level, hopefully most of you, you'll see that this is what you would call integration. We're heading towards integration doing this, which is very exciting. Okay, that's the knowledge you need for today's lesson, guys. You now need to answer the questions from the worksheet. Now, it's all of the questions. Again, I would advise printing off the worksheet first. It'll be much easier to answer these on paper. Work your way through them. We're going to have another lesson on this on Tuesday, but I want you to make a start on it for sure. So you need to make the notes from this video in a book or in paper if you're keeping paper records, and then you need to print off the worksheet that's going to be attached on Show My Homework and answer that on the paper itself, and then we'll continue with this on Tuesday. Okay, guys, have a good weekend, and I'll see you again soon.